Hello everyone. In today's lecture, we are going through the forecasting error and the calculating methods. Before we start, we have to take a overlook of previous lecture. In previous lecture, we go through the judgmental forecast. In that judgmental forecast, we see the executive opinion, Salesforce opinion, consumer surveys, outside opinion, and Delphi method. Judgmental forecasting it comes under the qualitative forecast. Then we see the time series forecast, in which we go through the trends, seasonality, cycle, irregular variation, random variation. Those are the various actual conditions comes while we are selecting time series forecast for any type of planning, and this time series forecast comes under the quantitative forecasting. These are the graphical representations of these variations, actual variations. These are the time series models which we have already seen: simple average method, simple moving average method, weighted moving average method, and exponential smoothing method. Then we take one example to explain each and every method. So for the simple average method, we take an example of TV sets. For simple moving average method, we take an example of refrigerator company or refrigerator supplier. For weighted moving average method, we take an example of restaurant. And for exponential smoothing method, we take an example of two-wheeler manufacturing company. To find out the forecasting demand, we take a forecast from past year and then average it, and then the value comes which is used for the forecasting future demand. Now we see forecasting error. So what is mean by error? Error in forecasting is nothing but the numeric difference in the forecasted demand and actual demand. So in the predicted or forecast value of a time series or any other phenomena of interest, since the forecast error is derived from the same scale of data, then the comparison between the forecast error of different series can only be made when the series are on the same scale. In simple cases, a forecast is compared with an outcome at a single time point, and a summary of forecast error is constructed over a collection of such time points. Here, forecast may be assessed using the difference or using a proportional error. By conventional, the error is defined using the value of the outcome minus the value of the forecast. In other cases, a forecast may consist of predicted value over a number of lead times. In this case, an assessment of forecast error may be needed to consider more general ways of assessing the match between the time profile of the forecast and the outcome. So, if many applications of forecast is to predict when certain threshold will be crossed, or one possible way of assessing the forecast is to use the timing error, the difference between the time between when the outcome crosses the threshold and when the forecast does so. When there is a interest in the maximum value being reached, assessment of forecast can be done using the some 3 points. Those are the difference of time of the peaks, the difference in the peak value values in the forecast and outcome, the difference between the peak value of outcome and the value of forecast for that time point. These are the three important points. Those are assessed while doing finding of the error. So, forecast error can be a calendar forecast error or a cross sectional forecast error. When we want to summarize the forecast error over a group of units, if we observe the average forecast error for a time series of forecast for the some product or phenomena, then we call this calendar forecast error or time series forecast error. Once again, I repeat, forecast error can be a calendar forecast error or a cross sectional forecast error when we want to summarize the forecast error over a group of units. So if we observe the average forecast error of for time series of forecast for the same product or same phenomena, then it will be called as a calendar forecast error or time series forecast error. If we observe this is a multiple products for the same period, then this is a cross sectional performance error. So for that purpose, reference class forecasting has been developed to reduce that forecast error. Now we see the combining forecast error to reduce the forecast error. In this type, we combine both multiple products and the single product of the forecast error. So there are two types of deviation to calculate the forecasting areas. One is the MAD, means mean absolute deviation, and another one is a bias, are two measures that are used to assess the accuracy of that forecasted demand. So once again I tell you what is meant by forecast. It is the difference between the actual value comes and the forecasted value. Okay, and it may be noted that mean absolute deviation expresses the magnitude but not the direction of the error. So how we can calculate the mean absolute deviation? So mean absolute deviation calculated by using the formula of the sum of the absolute value of forecast error for all periods divided by number of periods. So we take the summation of forecasted error and divide it by the number of periods. And in bias calculation, we use the formula by sum of all forecasted error of all periods divided by number of periods. So in sum of all forecasted error, we have to take place a subtraction in between the forecasted demand and the actual demand. In another way, we can also say that the forecasting error is a parallel with the forecasting accuracy. The forecast error means the difference between the actual value and the forecast value of the corresponding period. So a good forecasting method will yield residual that are uncorrelated. If there are correlations between the residual values, then there is a information left in the residuals, means some points which are keep aside, which should be used in computing forecast. This can be accomplished by computing the expected value of residual as a function of the known past residuals. So the forecast we get that the value expected is differs from the zero. So a good forecasting method will also have a zero mean. If the residual have mean with other than the zero, then the forecasts are biased and can be improved by adjusting the forecasting technique by an additive constant that equals the mean of the unadjusted residuals. So there are some other type of errors in that: scale dependent errors, percentage error, and scaled errors. So in other measures, we consider that the business forecasters and the practitioners sometimes use different terminology. They refer to the PMAD as the MAP, although they compute this as a volume weighted map for more information. So when comparing the accuracy of different forecasting method on a specific data set, the measures of aggregate error are compared with each other, and the methods that yields the lowest error is preferred. One another point we have to check is a cross validation. It is a testing technique, or it is a training a test set. For cross sectional data, one approach to cross validation works. Those are considered by checking some points. Those are: select observations for the test set and use the remaining observations in the training set. So the compute the error on the test observations. Second one is the repeat the above step for n number of observations. Third one, compute the forecast accuracy measures based on the errors obtained. This makes efficient use of the available data, as only one observation is omitted at each step. For time series data, the training set can only include observations prior to the test set. So therefore, no future observations can be used in constructing the forecast. Okay, now we see the parameters which are considered while selecting the forecasting method. So there are several steps while selecting any forecasting method for your product. So a single organization may use several different forecasting method to anticipate the future of its various activities. So it having a different methods during the whole life cycle of a single product for the forecasting. So there are some points which are considered while selecting any forecasting methods. So those factors are as: first one is the availability and accuracy of historical data. Means you have to collect the all historical data related to that single product, and the availability of all data regarding that product. Then another point is degree of accuracy expected from the prediction. Third one is the cost of developing the forecast, means the cost assigned for that forecast. Fourth one is the length of the prediction period. Fifth one, time available to make the analysis. Sixth is the complexity of the factors affecting the future operations. These are the selection criteria for any kind of forecasting method. So how we can find out the perfect forecasting method? It is depend on the practice and the experience. So there is a one issue all managers are faced while they are forecasting. So the issue is cost versus benefit is always a critical issue to the management, and forecasting is no exception. Although the dollar values are lesser than in most other management decision. So first, a manager has to estimate the losses that might accurate from inaccurate forecast. This is essentially a forecast of the forecasting result and uncertainty compounded. Then the manager must evaluate forecasting methods in terms of practically and cost. So a balance is sought between making the best use of data to meet real needs and applying costly techniques that promises potentially greater accuracy but may require more information and competence than the available data. So this is the important factor while selecting any forecasting method. Thank you. If you have any doubt throughout the forecasting chapter or throughout the forecasting point, then comment below. And this is the basic two types of calculation to find out the forecast error, as I told you in this lecture. One is the MAT technique and another one is the Bayes technique. MAT technique means mean absolute deviation, and Bayes means the difference between the actual value and the forecasted value. Thank you.